We start, guys, as we start quarter three. Quarter three is really long. Go ahead. It's until March 22nd. It's very long. We have all of January, all of February, and almost all of March in quarter three. So it is long. Our test days are Wednesday, Friday this semester. Sometimes, in years past, they've let us use Thursdays because early release are Wednesdays and Fridays, and we can't test on an early release day. Like, we can quiz, but we don't have enough time in math to give a test. So a lot of times they'll let us use Thursdays as well. I have your first two quizzes. They're in Canvas. They're up on the board, but you have a quiz on Tuesday the 17th. You guys do not have school on Monday the 16th. So we're going to learn all week. We're going to finish chapter 3. We're going to do 3-5 today and tomorrow. We're going to do 3-6 Wednesday, Thursday, Friday. Then you guys are off Monday. Your quiz will be on Tuesday. So just make sure you're paying attention to that. And then your second quiz, we're going to start chapter 4. Your second quiz is on January 26th. So go ahead and pull up your notes, please, for 3.5. We're going to review some stuff that we've already talked about. And we're going to learn, not a new concept. We're just going to look at, it's just a bunch of stuff that we've done that we're going to kind of pull all together. But if you're asked to factor something completely, you're going to factor completely. I want to know what all the answers are, what all the zeros are. So first thing we do when we factor is we look for GCF. Then we see if we can factor into a trinomial or we try to group. And then if all else fails, we have to use P over Q. So in this case, the first thing you're going to do is look for a GCF, which there is not one. So now if I group this, let's see if this groups nicely. What can I take out of the first set of parentheses? X squared. Okay, so take out your X squared. And then you're left with X minus 3, correct? What can you take out of that second parenthesis? A positive 1, so plus 1, and then you're left with X minus 3. So your new GCF is X minus 3. We write it one time out in front. And then the leftovers get their own parenthesis. All right? Now we're factoring. That's the complete factorization. If you're going to find all the zeros, you find out what X equals. But how many answers do you have here? There's 3. You have 1 real and 2 imaginary. How do I know already, just by looking at this, that 2 of them are imaginary? X squared. When I move that plus 1 over, it's going to become negative. Then I'm going to take the square root. So just notice here, you have X equals 3. And then here you have X equals plus minus I. Because when you set X squared plus 1 equals 0, when you move the plus 1 over, it becomes negative, and then when you take the square root. So we do have 3 answers. This one is real, and these 2 are imaginary, correct? Yes? Now, in the original problem, this is your original polynomial. Did you have any i's in it? No. So you can't tell right away just by looking at a polynomial if there are imaginary solutions. You will not have i's in your original polynomial, and that's going to come back. We're going to look at that in a second. All right, just kind of remembering that. When we talk about multiplicity, just remember what multiplicity means. If you have multiplicity an even amount of times, 2, 4, 6, 8, this tells you something about the action at the x-axis. What's going to happen at the x-axis if you have multiplicity in even number of times? It's going to bounce or touch and turn, whatever you guys want to say. But it's going to hit that point and go the other direction. What happens when you have multiplicity an odd number of times, like 3 or 5? What's it going to go? What's it going to do at that point on the graph? It's going to go through. It's going to pass through. So just remember, pass through, go through, however you want to say it. Just remember what multiplicity means in terms of a graph. Multiplicity means you have the same zero, the same answer, more than one time. Okay, this is, we just talked about that. This is just a little chart to kind of show you. Degree is your highest exponent. This is what the polynomial would look like. Zeros are your answers. And then however many answers you should have is the number of zeros. Whatever the highest exponent is, if you notice, it matches how many answers you have. Okay? You with me? All right, so now I want to talk to you about, we're going to find polynomials with given zeros. And then we're going to find all of the answers, all of the zeros. You'll see what I mean in a second. Letter A says, find the polynomial with the degree of 4. That means the highest exponent is what? 4. And they gave me these zeros. They gave me the zeros of x equals I, x equals negative I, x equals 2, and x equals negative 2, right? So how do I find the polynomial? What did we do? We did this before break. Okay, they're equal to, we're going to go backwards, yep. So if I move positive I over, this becomes x what? Minus I. If I move negative I over, this becomes x plus I. This becomes x minus 2, and this becomes x plus 2. Now, what did I tell you? We just talked about this a second ago. In your original polynomials, when you were trying to find answers and stuff, did you have any i's in the problem? No. So it's okay, guys, to have i's in your work, but you should not have any in your final answer. Because what's going to happen is through algebra, when you guys combine these together, the i's are going to cancel out. Watch. What's x times x? X squared. What's x times I? Plus xi, okay? What's negative I times x? Well, minus xi. And then what's negative I and a positive I? Minus I squared, right? Okay, guys, as soon as you see I squared, what does that mean? You cross it off and change the sign, so it's going to be plus 1. Now, what do you notice happens here with a positive and a negative xi? They cancel. So what you really have here is x squared plus 1. And then over here, if we FOIL, x times x is x squared. X times 2 is plus 2x minus 2x minus 4, right? So you're left with x squared minus 4. The two x's cancel out. And now when we multiply, x squared is x to the 4th. X squared and negative 4 is minus 4x squared. 1 and x squared is plus x squared. And 1 and negative 4 is minus 4. Everybody with? Now what happens when we combine like terms? X to the 4th minus 3x squared minus 4 equals 0. Or f of x, g of x, p of x, whatever. But do you notice how, yes, we know that two of the zeros, two of your answers were imaginary, but I don't have any i's in my polynomial. You should never have i's in your answer like that. They should somehow cancel out as you go through with your algebra. Okay, I'm going to set the next one up, but I'm not going to do it. It says you have a polynomial with a degree of 4. How many answers do you have? 4. All right, let's write them out. X equals negative 2. X equals 0. What are the other two? I have how many negative 2's?
3.
I have 3 of them. How do you know you have 3 of them? Because it says a multiplicity. What do you guys notice about all 4 of these answers, these zeros? Are they real or are they imaginary? They're real. So you would just set all of these to be x plus 2, x plus 2, x plus 2, then you times with x, multiply it together, you're good to go. All right? You guys with me? Okay, this is a very important slide. This is a very important statement right here. It says whenever a plus bi is a 0, its complex conjugate, a minus bi, is also a 0. Meaning, say they tell you, okay, one of your answers is x equals 2 minus 6i. When they give you a complex 0, meaning it's a real part and an imaginary part, they're giving you 2 answers, not just one. Because if I was going to multiply this back together, what should happen with my i's? They should cancel out. Well, I don't have anything to multiply it with. I don't have anything to make the i's cancel out. But the way we do that is by using the complex conjugate. So if I know that one of the zeros is 2 minus 6i, what's another one of the zeros? 2 plus 6i. Good. Always, 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 you have to account for the conjugate. So whatever they give you, a 0 that has an imaginary part and a real part, you have to account for the conjugate as well. have to account for the conjugate as well. Let's look at an example. All right, it says find the polynomial with the degree of what? Degree of 3. That means x cubed should be in your answer. They told me that x equals 1/2, and they told me that x equals 3 minus I. That's only 2 answers. Would you guys just tell me how many should they have? 3. So I have x equals 3 minus I. I also have x equals what? 3 plus I, the conjugate. Good. So if we're going to set this up to multiply, x minus 1/2. If I move 3 minus I, look, think about this. I'm moving it over here, right? So it's going to be minus, and then I have 3 minus I. And then when I move this over, it's minus 3 plus I. What do I need to do with that negative sign? Distribute it, okay. X minus 1/2, that's the same thing as writing 2x minus 1, right? Okay, so this is going to become x minus 3 plus I, x minus 3 minus I. Every single time when you guys have this, the beginning should be the same. See how this is both x minus 3? And the second sign should be different. Every time. Now, from this point, you can just multiply it out, which is what we're going to do. I will show you a shortcut. You guys are welcome to use the shortcut if you want to. If you don't see it, if it doesn't make sense to you, the shortcut, then don't do it. That's fine. I'm going to leave 2x minus 1 out in front. All right, we're going to come back and deal with that in a second. 2x minus 1, we'll multiply that in a minute. But let's go ahead and distribute these second 2 parentheses. So x times x gives me x squared. X times negative 3 is minus 3x. X times negative I is minus 3i. So now the middle, negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. Negative 3 times negative I is plus 3i, right? Now I times x is plus xi. I times negative 3 is minus 3i. And I times negative I is minus I squared. Everybody with me? Okay, so now there's a lot of cleaning up to do. First thing I see is as soon as I see I squared, I cross that off, and I make it a negative 1, right? So a negative 1 just would be plus 1 here. So let's see if we can combine anything. Anything combined with x squared? No. All right, what about negative 3x? And negative 3x gives me what? So minus 6x, okay. What happens with a negative 3i and a positive 3i? Cancels. I have 9 plus 1 is 10. And then I have a positive xi and a negative xi. They cancel out. Okay. What do you guys notice? Where did your i's go? They canceled out. So now we're just back to a normal polynomial. I know that when I factor it, to get my answer, 2 of the answers are imaginary because I was given an imaginary one, but you can't tell just by looking at it now. So now we would just multiply. 2x times x squared is 2x cubed. 2x and negative 6, so negative 12x. 2x and 10 is plus 20x. Negative 1 and x squared is minus x squared. Negative 1 and negative 6 is plus 6x. And negative 1 and 10 is negative 10. Did I not put it? Sorry. Thank you. So now f of x, p of x, h of x, however you want to write it. But I have 2x cubed. Negative 12 and a negative 1 is negative 13x squared plus 26x minus 10. So there's your polynomial. Now, I'm going to show you the shortcut that will work every single time if you guys do it correctly. If you don't, you can just FOIL it like we just did. But here's the shortcut. All right, I'm going to take this right here and do something here. What do you notice is highlighted in yellow? X minus 3, okay? So I'm going to write x minus 3, and I'm going to square it, because I have two of them. What else do you notice is the same in the parenthesis? The i's. I have I, and I'm going to square it, because I have two of them. Notice these two signs. Are they the same, or are they different? They're different, so put a difference sign in the middle. All that is, x minus 3 plus I, x minus 3 minus I, is the difference of perfect squares. Like if you had x plus 3, x minus 3. If you had x plus 7, x minus 7. It's just the difference of perfect squares. Every single time this will work out, guys. If I FOIL this, I have x minus 3 times x minus 3, right? X times x is x squared. X times negative 3, negative 3x. Negative 3 and x is negative 3x. Negative 3 and negative 3 is 9, right? Well, at the back end, what is I squared? Negative 1, right? What's a minus a negative 1? Plus 1. So when you combine here, you get x squared minus 6x plus 10, which isn't that the same thing you got right there? That will happen every single time. We're going to do a couple of these. If that doesn't make sense to you, if you're looking at that, you're like, what? That's fine. You can just multiply it out with the xi's and all that stuff. That's fine. But that is a shortcut. That's a pattern that will happen every time. Let me do another example. I'll show you what I mean. Say you have x equals 4 minus 3i. Okay, if I have x equals 4 minus 3i, what else do I have? X equals 4 plus 3i, right? So if I'm going to multiply these two together, I'm bringing this whole thing over here. So I have x minus 4 plus 3i. I'm bringing this whole thing over here. I have x minus 4 minus 3i. The first sign stays the same. The second sign changes. So from this point, you could go ahead and x times negative 4, x times negative 3i. Or you could say, wait a second, there's a shortcut here. I have x minus 4 how many times? Twice, right? So I square it. What's the second term that I have? What's the second term that I have? 3i, okay. And then what sign goes in the middle? The minus. So if you're going to work this out, you have x minus 4 times x minus 4. So x squared. Negative 4 is going to give me minus 8x. And then negative 4 times negative 4 is plus 16, right? Minus. Now this 2 goes to both of these. What is 3 squared? 9. And then I squared is negative 1, right? So if you have minus a negative 9, what does this become? Plus 9. So this is x squared minus 8x plus, what's 16 plus 9? Mm-hmm. Yep. Now, that will work every single time. If you don't like that, you can go from this step right here and say x times x times negative 4, x times negative 3i. Negative 4 times x, negative 4 here, and the i's will cancel out like it should. It's just a shortcut that the same thing will happen every time, so it just kind of saves some time. Questions? All right, let's look here. It says we use irreducible over the reals. Irreducible over the reals. We talked about this a little bit. Irreducible over the reals means I only want real answers. In a case like this, where it says factor it, all right? This is a trinomial. What times what gives me x to the 4th? It'd be x squared. What are the factors of negative 8? They're going to multiply to give me negative 8, but add to give me 2. Plus 4 and minus 2, correct? How many answers do you have here? There's 4. How many of them are real?
2.
2 of them are real, and 2 of them are imaginary. Which ones are what? Yep, negative 2 is real, because think about it. If I move this over, I get x squared equals 2. Take the square root, I have x equals plus or minus the square root of 2. Not a beautiful number, but it's real. But here, if I move the 4 over, I have x squared equals negative 4. When I take the square root, I get x equals plus minus 2i. So if irreducible over the reals means you would just leave it like this in its factored form. That's all that means. All right, I want to do these examples. I'm going to do 2 with the write the polynomial. And then we're going to do the last 2 together. You're given these zeros and you have to write the polynomial. Remember, if you have an imaginary, you have to account for the conjugate. So in number 5, I have x equals negative 7. I have x equals 2 plus 3i. And I also have what? 2 minus 3i. Leave the real one alone. Yes, you're starting off with imaginaries, but you shouldn't have any i's in your answer. So leave that real alone. I'm just going to write this over here, x plus 7. If I take this whole thing and bring it over, this becomes x minus 2 minus 3i. If I bring this one over, I have x minus 2 plus 3i. Remember, first sign stays the same, the second one switches. I'm going to go ahead and use the shortcut. I'm going to rewrite that x plus 7, hang out in front. My shortcut, I have x minus 2 twice. What else do I have twice? 3i. Stick it right here. And then what sign goes in the middle? The minus. So my x plus 7 is still hanging out. If I FOIL this, x times x is x squared. Negative 2x and negative 2x is going to give me minus 4x. Negative 2 times negative 2 is going to give me plus 4. And then what happens here? I have minus, this 2 goes to the 3, so 3 squared is 9. And then I squared is negative 1, so this is going to become plus, correct? So I still have x plus 7 hanging out. And this is x squared minus 4x plus 13. Now, do I have any i's left in my problem? No. So now we're just going to distribute. Just basic algebra that you guys have done 19 million times, but you should not have any more i's in your answer. So x times x squared is x cubed. X times negative 4 is negative 4x squared. X times 13 is plus 13x. 7 times x squared is plus 7x squared. 7 and negative 4 is minus 28, right? And then what's 7 times 13? Okay, so plus 91. So your final answer would be p of x, h of x, q of x, whatever. So x cubed plus 3x squared. What's 13 minus 28? 15? Okay, so plus 15 or minus 15? Minus 15 and then plus 91. There's your answer. Questions? All right, so that's pretty basic, pretty straightforward. We did all of that to be able to answer questions like 7 and 8. It says use the given 0 to find all of the zeros of the function. All right, we've used P over Q and all that stuff to find solutions, to find our answers. This is another way to do that. If they give you one of the zeros, right, they told me that x equals 3 plus 2i. What did they also tell me? X equals 3 minus 2i. Okay, so look at this problem. What is the highest exponent you see? A 3. So how many answers are there? There's 3. They already gave me 2 of them. We have to find the last one. What you're doing, guys, when you're finding the remaining zeros, when they give you the complex ones, there'll be 1 or 2, sometimes 3. They'll be real. But the way that you have to do this, let me ask you last period, can't you just use synthetic division? It doesn't work like that. The first thing you need to do is you need to multiply these two together. So I'm going to do that. I have x minus 3 minus 2i, x minus 3 plus 2i. Now, you can multiply from here or use the shortcut. I'm going to use the shortcut. I have x minus 3 squared. I have 2i squared, and my minus sign goes in the middle. So when we FOIL this out, x times x is x squared. Negative 3x plus negative 3x is minus 6x. Negative 3 times negative 3 is plus 9. And then I have a minus sign. Remember, this 2 goes to both the 2 and to the I. So 2 squared is 4, and I squared is what? Negative 1, so this is going to become plus 4. So I end up with x squared minus 6x plus 13. You guys are like, okay, well, what was the point of that? The reason that we do that, we've just multiplied them together. You now take this and divide your original polynomial by that. So you have x squared minus 6x plus 13, and you're going to divide that into x cubed minus 11x squared plus 43x minus 65. And the beauty behind this, guys, is when you do this with this last step of long division, you will not get a remainder. It'll be something nice and pretty. It divides evenly. So first term into first term, x squared into x cubed goes x times. Get your subtraction ready before you multiply. So x times x squared is x cubed. X times negative 6 is negative 6x squared. X times 13 is plus 13x. Now, before you can combine, you need to distribute. So distribute the negative throughout. So 43 minus 13 is going to give you a positive 30x. Negative 11 and 6 is going to give me negative 5x squared. And my minus 65 comes down. First term into first term. X squared times what gives me negative 5x squared? Well, negative 5. Now, this every single time should work out like this where you have no remainder. Negative 5 times x is negative 5x squared. Negative 5 and negative 6 is plus 30. And negative 5 and 13, what do you think that is? Yep, negative 65. Go ahead and distribute. And then what do you notice everything does? It cancels. So you're left with x minus 5. The question was find all the zeros. Well, how do I find the 0 if I'm left with x minus 5? X minus 5 equals 0, so x equals what? 5. When you find the remaining zeros, when you go ahead and do your long division and all that stuff, you'll come out with a nice, real answer. It's a very long process, I understand that. But it's the same exact way every time. Let's do the last one. All right, I have 2 zeros already given to me. X equals negative 2 minus 5i, and x equals negative 2 plus 5i, right? So when I go to multiply them together, I have x plus 2 minus 5i, x plus 2 plus 5i. This one's different because it started out negative, so when you move it over, it becomes positive. But if you notice, guys, same thing. I have x plus 2 twice. I have 5i here twice. And I have my sign in the middle. So when you FOIL, x times x is x squared. 2x plus 2x is 4x. 2 times 2 is 4. And then when I distribute here, I have minus 25, and I squared is negative 1, so this is actually going to become plus 25. So you have x squared plus 4x plus 29. Now, what do I do with that? I'm going to divide. I'm going to say, okay, I have x squared plus 4x plus 29, and I'm going to divide it into x cubed plus 11x squared. What is it? 57 and 203. Now, I know these numbers are gross. You guys are like, oh my gosh, but what should happen when you do this long division? Should come out nice and pretty. If it doesn't, then you did something wrong somewhere in your math. But x squared goes into x cubed x amount of times. So get that subtraction ready. X times x squared is x cubed. X times 4 is plus 4x squared. And 29 times x is 29x. Distribute, 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 distribute. What's 57 minus 29? 28. And then what's 11 minus 4? 7. So 7x squared, and then bring down your 203. So first term into first term. X squared times what? 7x squared, so plus 7. 7 times x is 7x squared. What's 7 times 4? 28. What do you think 7 times 29 is? It is 203. So then when you go through and distribute, everything cancels. So you're left with x plus 7 is equals 0. So what does x equal? Negative 7. Long process, but it's the same thing. When you're given zeros, you have to multiply them together to find the polynomial that you use for long division. Everybody with me?